so I hope you enjoyed it, and thanks a lot for watching, and catch you next time. Bye. And welcome to another episode of TRX Bench. Here today in the lab is a Yaesu FT7800. So that radio came in with a receive problem on VHF. So VHF is, as I've been told, completely deaf. So let's see what's really going on with this radio. Let's try to fix it. Alright, and we are right into testing here, and radio is on 2 meter and it is connected to the generator, and yeah, so you hear that is a very noisy signal, but it should be an S9 signal, but here our S-Vita indication is showing very low. And yeah, let's have a look on our communication tester. We are not already reaching a synod of 12 with minus 93. Yeah, let's have a look. Here we have it. So approximately 6 up to 7 dB synod. And frequency here looks not on frequency as well. You see that we have a very noisy audio, and that is what we clearly hear on our speaker as well. So yeah, let me simply increase here our signal. Now we are up to 20 dB, and you see how much I have to crank up here our signal, so that we are able to get a more or less good synod on one hand, and a more or less stable audio, but still in the background. Don't know if you can hear it over the camera. There is still noise in the background, and so we are still not reaching S9 on the radio. So you see we only have 3 bars here, which is clearly telling yeah, that is not good. So let's test it on 70 centimeter. And here the situation is completely different, as you can see. So this is now minus 93 dBm, and here we have really a clean tone. So that is looking just fine. So let's have a look onto the tester. And we can see we have here a completely different situation. So with minus 93 dBm, so we are easily reaching 30 dB synod, and you see we have really a clean audio. So that is all as it should be. Okay, but let's check for sensitivity if really everything is fine here on 70 centimeter. So let's search our 12 dB point, and you see that the tester has already started the routine. And we are at minus 120 dBm for 12 dB CNET, which should be approximately within the specs. So let me see, 0.5 for 12 dB CNET, which is just fine. So on 70 centimeter everything is fine, no problem whatsoever. So let's dig into our 2 meter band. Yeah, and I mean, it is almost 30 dB missing on receive sensitivity. Okay, so let's first have a look into our block diagram to understand a little bit how the 2 meter pass is working. Okay, and here's what we need. So let's zoom in a little bit. Okay, so you see here we have our antenna input, and what we clearly see here, we have here UHF, RX and TX, and we have here our VHF, transmit and receive. So we do not need to follow our UHF pass, so we are interested here in our VH pass, of course. And as we follow along here, we already see that we have here our antenna switch, and you clearly can read it here, TX VHF. And there we have finally the split between transmit, because this here is the transmit line, and if our switch is turned to RX, then of course we have to follow here our bolt line, and we have to go up here. Let's see. Okay, so there is another band which is 200 to 300 megahertz, and is there another one as well somewhere? Let me double check. No, only this both, and of course for us important is here up to 200 megahertz, because our 2 meter ham radio band is exactly in this area from 108 megahertz up to 200. Don't know if you can read it, so let's zoom it in a little bit more, then it might be clear. Yeah, you can see it here, 108 up to 200, and that is exactly where we need to find our pass. And this year the Q1008 seems to be the first front-end transistor. So that all is very important, but we do not get enough information here So we really need to dig a little bit deeper. I mean, we have here some front-end diodes which are important as well, and maybe you can see it here. We have some diodes here in our antenna switch, and as well here diodes which all could be the problem up to our first front-end transistor. So, as I said, let's go into the schematic because we need to dig a little bit deeper. Yeah, and now it really helps if you have both side by side, the block diagram and the schematic, because the schematic for its own is a little bit confusing because you have all the filtering here, and you really need to find your way through, and therefore we have seen here our antenna input, which is obviously here, this test point. And important to us is that now, as we are trying to follow here our VHF path, we need to find all of these diodes to know the way through. And as we can see here, so D1073, D1072 must be on the way to the first front-end transistor. And if we go over here, so let me increase it a little bit as well, and you may see we follow here along, and we have here a lot of filtering, so we see it here all over. But important to us are these both diodes, 1073, 1072, which is this section here. And now we are searching for 1074, 1075, which are the diodes down here. Still not found our first transistor. So we follow along here on the block diagram, and we find here, what is it, D1015 and D1016, and you see if we are following along here, okay, so you see that we find here our D1016 and here the D1015, alright? And now if we follow along here and really go up here to the max, let me see, so we are still looking here for the 1008, and here we have our 1008, so that means we need to check if the signal is really getting here to this transistor at least. So let me once again check here the path. So obviously it is here the D1015 over this coil, and if we follow along here, let's see, so it looks like that the path is going up to one of this gate here, gate 1 most likely, because gate 2 is setting here the gain of this dual gate transistor. Okay, and you see, yeah, we have here a voltage indication, and that is then obviously valid for the input level, which is described here at our antenna input. So anyways, that means let's radio crack open and let's follow first of all the path from the antenna input to gate 1 of our first front-end transistor. So that is the plan, what we really should do first. Okay, and here we have the main board, and this is a double-sided board. So as far as I can see it, we have all the transmitter parts are most likely here on this side. So this is here the final stage, and here the output filtering, and here we have it looks like the audio amplifier, and here we have our main processor. This here seems to be a receive filter. Well, the only way now is to look here into the board plan to see where we find our diodes, our first front-end transistor. So yeah, so board plan, and then let's look out for the parts we need to check. Okay, and when I look here onto our part list, I can easily find our Q1008. Let's see that you can see it as well. So here is our 1008, okay, so our FET transistor, right? And if I go over here, what is it? It is the fourth part under this line here. We see 1, 2, 3, 4 that it is on side B of our PCB, and that is underneath. So we cannot get to the needed transistor by easily checking it here as it is. So it looks like that we really have to take out the board, and then we might be able to get to our part, but then we have the issue that we cannot cool the parts any longer, because the chassis is not any longer together with the board, where are all the parts, like the audio amplifier is on, and the audio amplifier needs to get cold, or yeah, so we need the heatsink, right? Okay, let's see where we have the diodes.